My name is Wielgopolan. I work in Institute of Geophysics, Polish Academy of Sciences. And today we're going to talk about climate change. Well, most of my lessons are dedicated to some extent to climate change. But some scenarios related to climate change, to be more precise. And I would also like to discuss some consequences, debunk some myths, and talk about some physics principles, laws behind changes caused by global warming. So sea level rise is one of the consequences, and I started with a tricky question: is it time to build an ARK? Does it mean we'll have to face a flood like the ones that were described? Well, exactly. Where were they described? In many places, in many histories, in many records of human history, there is a history of the Great Deluge. That means Megaflood, the Great Flood. So stories of great ancient floods happen in mythology of hundreds of cultures. It's not only the Christian Bible, Bible, it's the Old Testament. But in many other cultures. So Westerners might be most familiar with the story of Noah. It is told, like I said, in Old Testament, book of Genesis to be exact. But a great flood, an event that impressed people, ancient people, so much, is reported in folklore from around the world, in Middle East, in Americas, in India, in China, in Southern Asia. And they're actually, the very strange thing is that they're very similar. For example, there is, I think you're familiar with the myth of Noah. It doesn't matter if you're Christian or not, it's just very present in culture in general. But for example, in ancient Babylonian flood myth, there was a myth, Epic of Gilgamesh. It tells a story analogous to that of Noah and his ark. There is a man, he was called Usnapishtim. He built a ship to save his family and animals from floods, and floods were brought on his city by God because the city was sinful. So in this case, after 7 days, this guy Usnapishtim and his family come to rest safely on a mountain top. And if you remember the story of Noah, there was 40 days of rain, like the Bible, the Genesis book says. It describes a worldwide flood, so-called Noachian flood. It is said that it covered even the highest mountains of the earth, and there was a construction of this huge boat that was supposed to save the mankind, actually only the family of Noah and animals. He took a couple of each species present on Earth, except fish, I believe, because that wouldn't make sense. And as a result, the mankind and animals survived. So the Bible says the rains were created by God. It lasted for 40 days, and that the surface of globe was covered with water for 150 days. Of course, we know that stories of that kind, well, they carry some history, but they exaggerate a little bit, to say the least. For example, it starts with, in the 600th year of Noah's life. So Noah was supposed to be 600 years old. Well, that is too much. So we know that, well, there are some facts, but it's very much exaggerated. But the description of Noah's Ark was so precise, so those directions that supposedly God gave to Noah for building the ark, that it was possible to recreate it and know how it was supposed to look like. And this is actually something that was recreated, and you can visit it. It's a full-size interpretation of Noah's Ark. It's in Netherlands. It's a museum in Netherlands. Of course, the animals are fake, but the size of it and the materials, it's all like it was described in this Genesis book. It's actually Netherlands and in Dordrecht, so you can visit it. A very specific construction, I must say, with this flat bottom. So, well, from one hand, it's hard to believe that the whole Earth was covered with water for 150 days, but if such myths reappear in different cultures, in different areas, then we start to think that maybe there was something of this kind that really made a great impression of on people who didn't understand how nature works, and they thought it was the anger of God that made it this phenomenon happen. But actually, maybe there was an event of this kind. So the scientific community doesn't doubt the possibility of a great flood. But there is no one answer. How did it look like exactly? When did it happen? Where did it happen? And why did it happen? Well, what do you say? What if we assume that the history of Great Flood is real? What could possibly cause this Great Flood? Let's put aside the religious part, anger of God. From scientific point of view, what do you say? What could possibly cause this kind of event? For sure, it didn't cover the whole Earth, but from the perspective of ancient people, they thought it was covering the whole Earth. It was rather a local than a global event, but it did happen, and there are actually two dominant theories about it, how it happened. There are two scientific theories. One is suggesting that there was a flooding around the area that is now the Black Sea. And the other theory is about the comet that struck the Earth and caused devastating floods. So we know almost for sure that there was a flood, more local than on the whole Earth and on a scale that's described in the Bible, for example, about those theories. At the end of 20th century, at the Columbia University, there was a geologist, William Ryan, who proposed a theory that there was a great flood about 7,000 years ago, at the end of the last ice age. So at that time, the Black Sea, that we know now that is very warm, very dense, very salty, Black Sea was a freshwater lake. And there were some lands around this lake that were farmlands. And after the European glaciers melted, because it was the end of Ice Age, the Mediterranean Sea overflowed with a force that was very, very gigantic, like 200 times greater than that of Niagara Falls, for example. So imagine this giant wave, and it converted the Black Sea from fresh water to the salty water, and also flooded the area. So this was supposedly the original Black Sea, and then this area was covered. So the farmlands were flooded, and it changed completely the ecosystem of Black Sea. So this is one theory that scientists believe it was this event was described in many, many myths and legends. And then there is a second theory, and maybe there are two combined, that there is a hypothesis that there were comets and meteors that, and more, even more than we imagined, that hit the Earth throughout the history. So some scientists believe that about 5,000 years ago there was a comet that hit our planet and caused a giant wave. And it was like quite a large comet, like up to 5 kilometers 5 kilometers wide, and crashed into the ocean. of the coast of what now is Madagascar, and the result was worldwide chaos, including violent high tsunamis and massive hurricanes. And also the atmosphere was superheated and saturated with water vapor. So this was a terror for people who did it 5,000 years ago, so it's not that long ago. It was accompanied by a week of darkness because of material that was expelled into the atmosphere. And actually the first person to claim that theory, to claim that the comets were because of the Great Flood, was Isaac Newton. You can see him here. So these are the two theories, and but it wasn't, even if we assume that the Great Flood was real, the Great Flood described in the Bible or in the Book of Gilgamesh, there were several smaller floods that actually had a great impact on shaping the Earth, on making it the way it looks now. So, for example, Great Britain. Now, Great Britain is, of course, an island, group of islands. But Britain was separated from mainland Europe after a catastrophic flood. A long, long time ago, about 200,000 years ago. There are some sonar studies that confirm that there was a flood that crushed. You can see those white cliffs, and those cliffs were crushed by a giant catastrophic flood. It was caused by some event, perhaps an earthquake, and this is how Great Britain became an island or a group of islands. So floods had a great influence on history, politics, geography, everything that we know. The first thing to understand when we're talking about sea level in general, not only about those sudden catastrophic events, but sea level in general, is to understand the difference between global sea level and local sea level, because there are global trends that climatologists are mostly interested in, and also relative sea level trends, and those are completely different measurements. First of all, just as the surface of the Earth is not flat, I think we all agree on that, the surface of the ocean is also not flat. We can see the flat ocean, but actually it's round, like a globe, like Earth. So, in the other words, the sea surface is not changing at the same rate globally. It's not like it's growing evenly or decreasing evenly sometimes. There are some differences in some processes that influence what the sea level behaves like in some regions, like subsidence, like upstream flood control. There is a, for example, there are natural processes, of course, and anthropogenic processes like mining fossil fuels. There are changes in regional ocean currents, and there are several factors influencing how it looks like in a regional scale. So it also has a different impact in different regions, like in urban settings. Rising seas threaten infrastructure that is necessary for living, for jobs, for housing, for industries. Roads, bridges, subways, water supplies, and virtually all human infrastructure can be impacted, is at risk from sea level rise. So what is the scale that we're talking about? What do you think? The models say that the change will be like, I don't know, 1 centimeter in 100 years, 100 meters. What would you say? What would be your guess? What is the scale of predicted sea level rise? Actually, actually, there is no one good answer because it depends on lots of factors also, and there are some model variants, like for example, scenarios of greenhouse gas emissions. But approximately, some say it's between 30 centimeters up to 7 meters globally by the end of 21st century. Well, 2018 now, so the end of 20th century is from a climatology perspective not that long to wait. So from 30 centimeters to 7 meters, but every prediction says it will be a rise. And if there's a rise, then there will be some consequences. And the first obvious consequence are islands disappearing. And the missing islands are already happening. It's not that we are just talking about predictions, it's their reality, especially in the Pacific, for example. Already 5 tiny Pacific islands have disappeared because of rising sea level and its consequences, like erosion. And it's a very, very real consequence of climate change, especially on those vulnerable habitats like islands. So those missing islands were not inhabited by humans. They were small. They were ranging in size from 1 to 5 hectares, so not really big. But there are 6 other Pacific islands that had experienced lots of consequences, like land washed into the sea, entire villages destroyed, people forced to relocate. So this is, in case of those 5 islands, they're completely disappeared. But in other cases, the life of people who lived there was seriously impacted and endangered. For example, there was one Nuatambu Island, and Nuatambu Island is a Pacific island that is home to 25 families, and they lost 11 houses and half of its inhabitable area since 2011, in 7 years. Like the whole, I know it's a small scale, but like half of the whole country, from their perspective, just disappeared. So those habitats are specifically vulnerable. And actually, I don't know if you heard about Tuvalu. Tuvalu drowning was a sort of symbol of actual climate change and an evidence of something that is not a theory, but actually a country disappearing. So Tuvalu is one of the smallest countries in the world, after the Vatican, Monaco, and Nauru, another small Pacific country. So it's located halfway between Hawaii and Australia. For most of us, it seems quite exotic. And the global warming and sea level rise is especially dangerous for Tuvalu, since the average height of the island is less than 2 meters above sea level. And the highest point of the island is 4.6 meters. So now you understand why those islands are very, very vulnerable. People live there, they have their lives there, their habitats there. If their country disappears, they will be forced to migrate, and it will be climatically forced migration. So Tuvalu is one of the first nations, the whole nation, to experience the effects of sea level rise. So not only some parts of the island are flooded, but there's also some other consequences, like rising salt water is also destroying crops, food crops, like coconut, like taro, the plants, their existence, their economy is based on, and they cannot survive salty water. If they're covered with salty water, they die and have nothing to, they cannot survive. So Tuvalu is one thing that is facing all the consequences. For the researchers, actually, it might seem quite cruel, but Tuvalu is like a laboratory of actual consequences of sea level rise. But like I said, Tuvalu is in the middle between Hawaii and Australia, so we actually think, well, it's quite distant. is quite exotic from our point of view. But actually, it's not only the very distant island that will be impacted, like Tuvalu here, you can see, but you can see also very well-known cities, large cities like New Orleans that already experienced a large hurricane Katrina. And also in Europe, we have Venice, we have Hamburg, we have Amsterdam, and these are places that are predicted to disappear, totally disappear, because of rising sea levels. And this year, here is a date when they will disappear. So imagine Hamburg disappearing till 2150, Amsterdam disappearing till the end of the 21st century, and the same with Venice. So it's not like it's only distant, it will never touch us, actually. So let's look at this video dedicated to sea level rise in Northern Europe. You need to observe this disappearing areas. You can see how shape of Great Britain is changing. The ocean is eating the land. Also, you can see here this part of Northern Europe completely flooded. So this is to make you realize that it's not just about some distant countries that, well, maybe we'll not go to holidays there. It's very, very real and very, very close to us. But what I really would like to talk about today is some physical processes that are behind it. So, okay, maybe a quick question for you. Why do you think that, in general, sea level is rising? There is more water. Where does the water come from? Is it only because of greater amount of water, or are there some other reasons? The Great Flood was caused by, Bible says, 40 days of rain. And now we know that actually sea level is rising. Why is that? Okay, I'll make it easier for you. So the first thing might actually surprise you, but because it's not the bigger amount of water, but it's bigger volume of water that already exists on the planet. It's the expansion of seawater as it warms. So we know that the average temperature is rising, and as a consequence, without any additional water, without any melting, seawater already takes more volume than normally. And why is that? You can see it here on this image. This is what? Cold water or cold fluid, any fluid actually. And here you can see hot or warmer water. The particles are more separated, so the volume is greater. So even just because of this temperature rise, the sea level rise is real. So this rapid acceleration in sea level is mainly actually due to the thermal expansion of seawater. This is one factor, and the other factor is a large increase in volume, of course, caused by melting ice. There are also other factors that might not seem so obvious, like gravity. Gravity also has impact, influences the sea level. And for example, in Greenland, ice sheet melts, and the gravity change reduces sea levels in northwest Europe. On the other hand, melting of the West Antarctic ice sheet would have the opposite effect. Why? Because ice sheets, a bit like a moon, they attract gravity. They have the gravitational attraction. Of course, there is melting of land ice, mostly melting Greenland, Antarctic ice sheets, but also other human activities. Mainly our messing with groundwaters, wetlands, with draining wetlands, which is not good for many, many reasons. We change land use, so there is more water that is drained, that flows into the ocean instead of staying in the ground, in the wetlands, in forests, for example. So these are some less obvious factors, but of course melting of landlights, melting of Greenland, Antarctic ice sheets have a great impact, and you should remember also the expansion, the thermal expansion is also important. Of course, there are also some factors that decrease sea level. We're not that strong as the level of oceans is constantly rising, but there are some. Well, you will probably know, you were not born in 1991, but I actually remember, I'm old enough to remember Pinatubo volcano eruption. It was in 1991. It was one of the biggest volcano eruptions in 20th century, and it had major climatic consequences. And there were nearly 20 million tons of sulfur dioxide that were injected into the stratosphere because of this eruption. There was a dispersal of this gas cloud around the world, and actually it caused the global temperatures to drop temporarily, not a lot, but like 0.5 Celsius degrees. And those colder average temperatures literally slowed the rise of sea level. You can see it here, 1991, sea level rise, up, goes down. And it was like the Earth was covered in a gas blanket, in a dust blanket maybe. So it kind of, it's paradox, but this volcano eruption kind of prevented the estimate of, prevented acceleration. And because the Earth was covered in this blanket of cooling ash, so it was a bad thing and a good thing at the same time, actually. So there are some factors that actually decrease, but they're mostly catastrophic events, so we don't want that. But have you ever thought, how is it possible even to measure the level of the ocean, of global ocean? How do we know that the level is changing, whether it's changing, and what is the scale of this change? Well, you cannot simply stand on the ocean shore and try to measure sea level with a ruler and compare it. It would be impossible for many reasons. So there are two techniques that we are currently using. So the sea level is primarily measured using so-called tide stations. This is a tide station. So tide stations, and another thing are satellites. Actually, to be more exact, they are satellite laser altimeters. So, and they have different purposes. Like tide stations are placed around the globe and tell us what's happening at the local level. The height of the water is measured along the coast related to some specific point on land, some stable specific point on land. While the satellite measurements provide us with the average height of the entire ocean. So this is much more useful for climatologists. So, but taken together, those tools tell us how the ocean sea levels are changing over time. So we use both on land or on sea tools and satellite tools as well. But those are not perfect solutions. There are many factors that disrupt our measurements and make it a little bit less exact, so we never have definite results. Of course, there are tides caused by moon, like I said, gravity, attraction of moons. There are waves caused by winds, the tides. Of course, differences in pressure like high pressure areas and low pressure areas in the atmosphere, actually change the surface level of the ocean. The difference may not be that big, but actually the differences in general are not that visible. So even the smallest difference, disruption of measurement matters. And temperature changes in the ocean that, of course, change density and volume of the water do have an impact of accuracy of those measurements. Plus, some obvious facts like sudden additional rainfall, river water flowing into the ocean in particular place. This may all disrupt this general image. So we have our measurements, but we also have our models and our predictions, we might say. This is only a prediction. I mean, this one is and this one is. Predictions of storm surge, of high tides magnified and impacting the coastal areas. So the scale of annual rise is for now is about 3 millimeters per year. This may not seem a lot, but it is constant rise year after year after year after year. And so this is how we get up to 7 meters in change in level. But this is only one of the scenarios. And if the 7 meters scenario happens, 7 meter rise in sea level, on average, that would mean the end for, like I said, several Pacific Island nations, but also Bangladesh, Netherlands, the more European-centered, parts of Eastern Britain, Florida, several coastal cities that I showed you before. And there is also a lesser-known possible effect, but also really dangerous weather. So the best possible effect would be blocking of the Gulf Stream. The Gulf Stream is a warm ocean current that is making Western Europe and Eastern US warmer. And blocking the Gulf Stream by melting water from the Greenland ice cap would mean drastically lowering temperatures in Western Europe, and that would mean something very paradoxical, but a new ice age in Europe and Western Europe and Eastern US. So, if you see this kind of head title in a newspaper, look out, the icebergs are melting, we are in danger. What do you just say? Do you recognize this guy shouting Eureka, jumping out of his bathtub? Remember Archimedes Principle? Archimedes Principle is also known as physical law of buoyancy. It was discovered by the ancient Greek mathematician, inventor Archimedes, and he stated that anything, a body, completely or partially floated or submerged in a fluid, like in water, has some power impacting it. It's acted upon by an upward, buoyant force. That's why it doesn't drown. The force, the magnitude of which is equal to the weight of the fluid that was displaced by the body. This might seem a little bit complicated. So, in general, if I'm in a bathtub, so the volume of the water that is displaced from the bathtub is equivalent to my volume, to the volume of object that is immersed in a fluid. What does it mean to us? It means that in general, the melting of floating sea ice, and floating sea ice is also icebergs, should, and let's stay with should, cause no change in sea level. And let's look at this experiment that proves that. is something you can do easily at home. You can see the ice melting. And the cat not melting. Less and less of the ice, and the water level remains the same. Okay, I think we've seen enough. So normally we would say that there is no change if we do that experiment, there is no change in sea level or water level when the ice melts, because the ice was already in there and was pushing up the amount of water equal to its volume. So whether it's in this form, on this form, whether it's solid or whether it's fluid, it's still the same sea level. That's what we would normally say based on Archimedes principle. Or maybe not. So yes, Archimedes was right, of course, and we're not going to contradict his statement. But let me just tell me one thing. Are icebergs or glaciers fresh water or salt water? We know that they're surrounded by the ocean, the Arctic Ocean, for example. But icebergs and sea ice glaciers, either salt water or fresh water? Fresh water, exactly. And why is that fresh water? Because the salt is left behind, right? When it's freezing, the water is freezing into the ice. The salt is not trapped inside, so the ice is fresh water and it's surrounded by salty water. Okay, so here's one thing. So once again, is it really 100% true that melting icebergs do not cause sea level rise? Actually, the answer is already here, but I just wanted you to think about it for a moment. You can make this test also at home. So let me get this straight. Most of the contribution to sea level rise comes from water and ice moving from land into the ocean. So ice sheets, so glaciers. But it turns out that melting of floating ice causes a small amount of sea level rise too. So globally, it doesn't sound like much. It's like 0.05 millimeters per year. But actually, first of all, if all this sea ice currently floating in the oceans were to melt, it could rise sea level by 6 centimeters. So that's a lot. And you remember that per year it's like 3 millimeters in total, from which 0.05 comes from melting floating ice. So that's quite a lot in comparison. How is it possible? First of all, because fresh water is less dense than salty water. So fresh water, of which icebergs are made, is less dense than salty water. So while the amount of seawater displaced by the iceberg is equal to the weight, the melted fresh water takes a slightly larger volume. So the weight is the same, but the volume is a little bit larger than the displaced salt water. So this results in a small increase in the water level. So you know one thing, that if someone says that floating ice doesn't cause sea level rise at all, they're wrong actually. So it's additional. People say like 0.05 up to 0.3 millimeters per year. So it's not a lot. So here are some photos from current floods in Europe, just to show it's not just a problem of Pacific countries. And if you look at those, this is actually, I think it's Miami. So you can see that human habitats are very, very close to the sea. They're by the sea. They're almost like in the sea. You can imagine that if the sea level rise is not like 20 meters, it's like 7 meters, it will cause a major destruction in those coastal areas. And there are other consequences, not only just being flooded and this destroying of habitats, but some other less obvious consequences, like contamination of drinking fresh water, negative consequences for farming. The crops wouldn't cope with salty water. And not only crops, but also natural plant life, natural wildlife, animals and plants. And this whole would, of course, hurt our economy as we know it. So just to end our lesson, I would like to show you this image. Actually, it's a part of the Italian project, climateandproject.com. The guy that is trying to convince people that about some scientific facts like climate change, sea level rise in an artistic manner. So he's drawing those predictions of where would the water come, how high would the water come according to some predictions. You can also check this website for more. So thank you very much for today.